Welcome to an exploration of time, a concept we often take for granted. What if time as we know it is merely an illusion? Recent theories in physics suggest time might not be a fundamental aspect of reality, but an emergent phenomenon from quantum entanglement. Imagine a universe where time doesn't tick away independently, but is woven into quantum states. This idea challenges our conventional understanding and invites us to rethink reality itself. As we delve into this journey, we'll uncover how quantum entanglement might unlock the mysteries of time. This isn't just about abstract theories, it's about questioning existence and our place within it. Let's embark on this intriguing quest to understand if time is truly an illusion and what that means for our perception of the universe. Quantum entanglement is a phenomenon where particles become interconnected, influencing each other instantly, regardless of distance. This behavior forms the basis of a revolutionary theory about time. The Page and Wooter's mechanism suggests that time, as we perceive it, might emerge from this entanglement. Imagine time not as a linear progression, but as a byproduct of these quantum relationships. This challenges our traditional understanding, suggesting time could be more of an illusion than a fundamental reality. By exploring this concept, we open a new way of thinking about the universe, where time's flow is relative, shaped by entangled particles. This perspective reshapes our understanding of time and invites us to reconsider reality itself. As we delve deeper, we see the universe in a new light. Let's delve into a significant conundrum in modern physics: the inconsistency of time as perceived through quantum mechanics versus general relativity, known as the problem of time. In quantum mechanics, time is a background parameter, a steady backdrop for events. In general relativity, time is interwoven with space, dynamic and malleable. These differing perspectives create a profound challenge. How can time be both fixed and flexible? This inconsistency suggests our understanding of time might be incomplete. It raises the question of whether time is fundamental or an emergent property from deeper interactions. This problem of time isn't just an academic puzzle, it's a gateway to revolutionary insights about the universe. Exploring this challenge opens new possibilities in comprehending reality. While the theory of time as an illusion from quantum entanglement is mathematically consistent, it faces a critical hurdle: experimental validation. Without tangible evidence, the scientific community remains cautious. To move from theory to acceptance, experiments must prove that what is mathematically sound can be observed. This involves testing the dance of entangled particles and their influence on time perception. Only then can we truly understand if time, as we experience it, is indeed an illusion. This pursuit of evidence is essential, not only to validate the theory, but to unlock new realms of understanding in physics and beyond. As we delve deeper into quantum mechanics, a fascinating possibility emerges. Classical physics, the foundation of our everyday understanding, might arise from the quantum world. This idea challenges traditional notions of time and reality, suggesting that what we perceive as solid could result from complex quantum interactions. Imagine the implications. Our linear experience of time could be just a byproduct of these deeper processes. This perspective reshapes our understanding of physics and invites us to reconsider our place in the universe. As we explore these concepts, we stand on the brink of a new era in scientific thought, potentially redefining reality itself. In conclusion, our journey through the concept of time as an illusion invites us to rethink reality's fabric. As quantum entanglement challenges traditional perceptions, it opens new pathways for understanding. The potential for groundbreaking discoveries is vast, but requires further research and experimentation. By questioning the fundamental nature of time, we stand at the threshold of a deeper comprehension of the universe. Let us remain curious and continue to explore the mysteries beyond our current grasp.